I will introduce a technique to measure inductance with an oscilloscope. We know an oscilloscope can be used to measure AC voltages and phase angles. Let's think about constructing a simple RL circuit. We can use the voltage relationship in the circuit to calculate the inductance. So here we have a simple RL circuit. Assume we know the resistance. We want to measure the inductance. So here we're constructing a circuit in AC domain. The power supply is a voltage source. Assume the sinusoidal voltage has a frequency f. So the reading frequency should be 2 pi f. So in the phasor domain, the impedance of resistor is just the resistance R. The impedance of inductor is j omega L. So ZR should be R. ZL is j omega L. Let's think about a special case. When the magnitude of the impedance of the resistor is equivalent to the impedance of the inductor. So the magnitude is equivalent. In that case, omega L should be equivalent to R. So L is R over reading frequency. So here we assume that we know the resistance. If we know the frequency of the power supply, we can calculate the inductance. That's under the condition that the resistance impedance and also the inductor impedance, the magnitude is the same. So let's think about under the condition that the equivalent impedances. So what's going to happen for the voltage? The voltage across the resistor is VR. The source voltage is Vs. In the phasor domain, VR over Vs. That is a voltage divider circuit. So VR over Vs should be the impedance of the resistance over the total impedance in the circuit, the two components in series. So ZR over ZL plus ZR. That's a typical voltage divider circuit. So under the condition that the two impedances have the same magnitude, so we just can simplify the ratio here. So the numerator and denominator are divided by R. 1 over square root of 2 at 45 degrees. The magnitude for constant 1 should be 1 and the phase angle is 0 degrees. So here 1 over square root of 2 is 0.707. So 0 minus 45 degrees is negative 45 degrees. So here if we make the resistor voltage phase angle with respect to the source voltage phase angle equivalent to negative 45 degrees, we can calculate the inductance based on the equation we just derived. So here, the phase angle difference between the resistor voltage and the phase angle of the source voltage is negative 45 degrees. Under that condition, we know the inductance should be R over 2 pi F. F is the source voltage frequency. We assume that we know the resistance in the circuit. So to measure the inductance, we need to set up a RL circuit first. So L should be R over 2 pi F when the phase angle difference is negative 45 degrees. Here's the inductor and we have a resistor. Here we use 1 kilo ohm resistor. And we have a power supply connected between these 2 points. So here's the positive lead of the power supply, the negative lead. We also use a oscilloscope to show both the source voltage and also the output voltage on the scope. So here is channel 1. This scope channel 2 is connected across the resistor. Channel 1 and channel 2 is across the resistors. So let's look at the waveforms on the oscilloscope. So we have Vs and Vr. So here we need to adjust the frequency and measure the phase angle of the resistor voltage. So auto scale, then quick measure. So auto scale, quick measure. Source 2, we can see the phase angle here. So we can select the phase angle. Click on select, then phase, measure phase. Here we need to adjust the power supply frequency to make the resistor voltage phase angle equal to negative 45 degrees. So here you can see when we change the frequency, the phase angle has been changed. So we need to adjust the frequency here to make the resistor voltage phase angle equal to negative 45 degrees. So now let's take a look at the source voltage frequency. It's 4.76 kilohertz. So this condition is satisfied. Now we can calculate the inductance. Inductance should be R over 2 pi F. In our circuit, we use a 1 kilo ohm resistor over 2 pi times frequency. The source frequency is 4.76 kilohertz. So the inductance is 0.033 Henry. That is 33 millihenry. So we cannot measure the inductance directly using a oscilloscope, but here we can try to measure the voltage phase angle first and adjust the frequency to make the phase angle equivalent to negative 45 degrees. Under that condition, we have derived that inductance should be R over 2 pi F. So the final result is 33 millihenry.